Hello all, welcome to my channel SPS Physics Classes by S. Panindra Sharma. Today, let us try to deal with a new problem. Determination of center of mass of a hollow semi-sphere. Suppose let us consider something like hollow semi-sphere where O is the starting point or origin of the system and this is x-axis and y-axis growth given here. And when you consider a smallest annular ring or something like a portion element which occupies in the form of around 3 dimension, okay, then the width of the ring is nothing but a dl, and the width that particular ring contains a observation radius of smaller, where the ring is at a height of y in the problem. Now the value of y is nothing but r cos theta by our imagination, and the radius of that imaginary circular ring is nothing but r sin theta in the problem. And the mass of the annular ring is nothing but surface mass density. What is meant by surface mass density? Mass of the object to the area called as surface mass density into length, entire area of this entire elemental length. That elemental length means what, Anna? Now this smallest value, it is considered as because of this dl, okay, even though it appear to be in the figure enlarged, okay, we have to imagine that is in the form of cylinder only. We have to consider fixed radius. Therefore the upper value r and the bottom line, this one, okay, upper one is r, bottom one also contains the same radius. Like that only we choose the value of dl. So 2 pi r into dl will give you the area of this entire annual ring. Therefore we got the value of dm. Now like terms are cancelled here, then upon cancellation we got the value of 2 pi gets cancelled. Therefore m by r square of what is meant by smaller already we got here, r sin theta. And what is meant by dl? Dl is nothing but simply we can write down as radius into angle at the center. That means you can write down as r d theta. We can write down like this. Therefore m into r square by r square sin theta d theta, one can write down like this. And further, when you cancel the like terms, we have the value of dm. Further problem is nothing but sin theta into d theta. We can write down with the initial multiple coefficient of total mass m. We have to consider like this. Now because of symmetrical distribution, x center of mass is 0 and we'll try to find out only y coordinate. That is enough for the problem. Therefore y COM is equal to integration of y dm by integration of dm we have to do. It is interesting thing that we just considered from here to here about 0 to 90 degrees, and here also symmetrical structure is there. So therefore it is better to consider over 2 times of actual value within the limits of integration 0 to 90. Therefore you can write down as 2 by total mass of the value is capital M I just considered here, and integration 0 to pi by 2. Y is nothing but how much, r cos theta we can write down, and dm value how much we got here, m sin theta into you can write down as d theta. Further this value is equals to m gets cancelled, this r comes outside, 2 into r integration 0 to pi by 2 cos theta into sin theta d theta we can write down. This is equal to r into integration 0 to pi by 2 you can write down as sin 2 theta into d theta. Why it is sin 2 theta? Because cos theta into sin theta into 2 sin theta cos theta, nothing but sin 2 theta we got. Upon solving this entire integration, we had the value of what, r by 2 into cos 2 theta, which are running over limits 0 to pi by 2. Upon substitution, we got the value of what, r by 2 as the right answer for the problem. Therefore the position of center of mass is nothing but, so x COM comma y COM given by x COM is 0 and y COM is r by 2. So by using this particular formula, one can determine the position of center of mass of hollow semisphere. So hollow semisphere contains exactly at the position of r by 2. That means here approximately here we get the center of mass of the system. Thank you.